class. I'm sorry I had to cancel class this evening. But for now, before we get started, please make sure if you are on the website, you have already downloaded in the logic folder under week 5 blank notes. Please make sure you've downloaded this and have it filled in for next class. I'll talk more about that at the end. I'm going to try and break this down into 5 to 10 minute clips per. Try and not go much over that. But all of the notes will be here, and you'll see they're a little bit different from what I'm actually going to work through. However, all except for one example will be worked through. So please bring this with you at the beginning of next class, and it will count as your quiz grade. All right, so for starters, we're actually going to nix 2.3 for tonight. It ended up being far too much because there was way more I wanted to talk about in 2.1 and 2.2 with logic. So on InfoShares, I noticed, I think Chad had posted about Boolean logic, mentioning that in the last thing I had brought up. And here we get to the idea of, this evening we'll be talking about logical form and equivalence. This is all section 2.1 in your textbook. However, what is a statement? So this is really something we base logic around. A statement is something that has a true or false value. It doesn't actually matter if it is true or false, but it must be something that can be declared as true or false. For example, below you'll see here, London is the capital of England. Shakespeare wrote the last episode of The Sopranos. Well, yeah, this one's true, but this is completely false. And then the US has the world's highest divorce rate. This one, who actually knows? But the point here is it does not matter. But what does matter is that we can, at some point or another, determine if it is true or false. So to continue on with this idea, we have something called logical equivalence, and we'll be talking about this more as the notes go on. For things to be logically equivalent, they have to equate down to the same thing, and we'll work a lot more with this with truth tables. Notice here the first statement. If Jane is a math major, or Jane is a CIS major, then Jane will take Math 253. Then we have another statement. Jane is a CIS major. Okay. Therefore, based on the two statements above, she will take MAT 253. Right. Now, if we look down below, if logic is easy, or if I study hard, then I will get an A in this course. I will study hard, which again is something directly out of what we have here. As we noticed above, Jane is a CIS major. Therefore, I will get an A in this course. Because both of these have the exact same form, again, they're considered logically equivalent, and we'll discuss this much further with truth tables. It's good to have a general overview as to, I guess, how we can equate English sentences back to logic, because this will come up again throughout the evening and it will be a recurring pattern. Now, we've already mentioned the idea of truth tables, and we'll get into that if you notice down here in slide 7. But where do these come from? We actually can't really work with English statements, but we do have to convert them to logical form, which is probably one of the most frequent things we'll have to do before using a truth table if that comes up. Along with this, what notation do we actually use for logical form? With this, we have some common letters. Most frequently that are used are P, Q, and R. You really could use any letters you'd like. However, when a mathematician sees P, Q, R, mind goes immediately to logic. Along with having some type of statements, well, we're used to saying the cat is black, right? Well, how would we negate something like that? We would say the cat is not black. Now, the way we notate negation in logic is using a little tilde and then whatever the letter is. So right here, this would read not P. Some textbooks might use a little symbol like this for not P. Just make note that if you're looking for references, this also means the not symbol. So anytime you see a tilde or this little squiggle bracket thing. Along with that, we have some, just like we have addition, subtraction with integers, rational numbers, etc., We also have operations with this, and this may remind you of what we had done with Venn diagrams. Um, when a conjunction is when you're intersecting things together. Along with this, for the idea of an intersection, we also come with the word but that will, especially when we're working with a statement. So this is notated by a little upside down triangle, or not upside down triangle, but just the upper half of it. And this is our and or our intersection. Now, where the word but comes into play is if we have a statement like, um, Joe is 5 feet tall, but he's kind of heavy. So that but can also mean the same thing as saying Joe is 5 feet tall and he's kind of heavy. Those are the same idea. So either of those in an English statement would go to our conjunction symbol, which is again our little top of a triangle. A disjunction, on the other hand, if we think here, conjunction means bringing these things together with an intersection. Disjunction, it's one thing or another. It's a little bit different than our ideas that we put with set theory, but this is again our or statement, notated by a little V shape. Notice that if we were intersecting in set theory, we would use that U shape, and we would use or I guess an upside down U, and then our U for a disjunction. Now this is our or statement. So this is that example I always go back to. We're talking about two roommates coming to live together, and you bring all your stuff. You don't necessarily keep two refrigerators there, but you do have things, lots of things coming together. When we're converting things to logical form, we have to note that order of operations tends to change just a little bit. We still have our parentheses first, but negations in a way can take precedence of that. The only time parentheses truly come first is if we have parentheses with some stuff inside and then a negation on the outside. If we have parentheses, negation of, let's say, x, and then some other stuff, and then negation of y, it has to be noted here that the negations actually come first within, and then we perform the rest of the operations within parentheses. Everything else after parentheses and negations, just read it from left to right. As far as actually converting some of these sentences, let's take, for example, the P equals the statement it is hot, and Q equals the statement it is sunny. If we have the statement that we'd like to rewrite in logical form, it is not hot, but it is sunny. Well, first thing we notice here is the not hot. Not hot is our not symbol with a P, and we have this but word. Recall here, but means that intersection symbol, the conjunction, and it is sunny. There's no variation on this because it's straight, it is sunny, exactly what we have here for Q. So this would be the same thing as saying not P, intersect, or conjunction Q. Whichever way you're more comfortable saying it, the book will always refer to it as a conjunction. We also have an example, it is neither hot nor sunny. There are several ways you could write this. Since it is neither, we could say not, parentheses, hot nor sunny. Well, hot would be P. This would be a disjunction, sunny, which is Q. This is one way of saying it. We could also say it's neither hot and it's also not sunny. Well, that's the same thing as saying. Note here the symbol, it'll come back again in a moment. This means logically equivalent. So it is neither hot nor sunny. We could say not P, intersect, not Q. What we've actually shown here, we will be proving later this evening, so stay tuned for that in the next couple videos. One last example, or a couple last examples we have here. Let P equals, it is after 5 p.m. Q, they are not working. So let's convert the statement. It is after 5 p.m., so that would be P, or, so P disjunction for the or, they are working, so P or Q. Now, in addition to this, we also have it is after 5 p.m. and they are not working. Well, P is not changed here, and we have our and statement, so that is a conjunction. They are not working. Not working is denoted by not Q.